Hi, in this video I'm looking at a couple of examples of solving for the general solution to some quick trig equations. So if I look at my first example where I've got the sine of x equals the square root of 3 over 2. Now to solve this we need to look at the inverse sine of that root 3 over 2, so that way we can get x on its own. Now, to do this, we first find what's the base angle given by solving for root 3 over 2. So if I look for the angle, which I'm going to get as an exact value from my 1, 2 root 3 triangle, which is pi over 6 and pi over 3. And the angle given for this, well, sine is opposite over hypotenuse. So if I want the angle that is opposite the root 3, well, that's going to be the pi over 3. So our angle is pi over 3. Now the base general form for sine is that value x is going to be n times pi plus the negative 1 to the n times that angle that we've just obtained. So if I put in my information, n is just how many rotations we've done, how many lots of pi. Pi is pi, negative 1 to the n, and I've just got to put in this pi over 3 at the end. Now let's just tidy this up and make this nice and neat and tidy. The first thing I'm going to do is we've got two separate terms here, so let's make them be one term. So this one is a divide by 3, so I want this one to also be over 3, which means I need to put a 3 on top. So that gives us that x is going to be 3n pi plus negative 1 to the n pi all over 3, because now they both have the same denominator. I can have them be over one denominator. Now the last thing we can do is they both have this pi in there, so we can factorize out pi. So inside the brackets I'm still going to have 3n, and I'm still going to have this negative 1 to the n, but on the outside I'm going to bring out that pi. And of course, we're still going to have over 3. And that's the general solution to our initial trig equation, sine of x equals root 3 over 2. And the reason it works is because if I think about it, the base solution was pi on 3, but sine gives us y, which means I've also got a solution over here. And then if I go around the circle, I get that solution again, and that solution, and that solution, and that solution as I keep going around the circle. Let's have a look at another example. Let's have a look at cos of x equals 1 over root 2. So again, I'm wanting to see what I get if I inverse cos 1 over root 2. And if I look at the 1, 1 root 2 triangle, which has the angle pi on 4 in both corners, that means that my base angle theta is pi on 4. And we can check that because cos is adjacent over hypotenuse. So I want an angle that's adjacent to a pi on 4, which is 1, and our hypotenuse is root 2. So now if we go to the base form for the general solution to this, that is that we have 2n pi plus or minus the angle that we obtain. So our general solution is going to be 2n pi plus or minus this pi on 4 we just worked out. And again, we can tidy this up. If I want them to be both over a denominator of 4, I've got to times the top of this one to be 4. And so that's going to give us x to be, well, on our numerator I've got 4 times 2, which is 8n pi, and left over we've got plus or minus just pi. And then of course we have over 4 still there. Last thing that we can do is factorize out our pi. And so I've got x equals 8 and pi, but no pi on top, so I'm going to factorize out that pi. Plus or minus, and if I've got 1 pi, I'm going to just be left with the 1 over 4, and we'll leave that pi out the end there. So there we have it. To solve for the general solution of trig equations, we first find what's the base angle for the inverse trig, and then put it into the general solution, and neaten it up by doing some fraction maths and some factorizing.